Good morning students, I am Professor Arvind Mudegaon. Welcome you to the design lab, and today we are going to study about Rosette strain gauge. Okay, the aim of the experiment is to measure the principal strain on a thin walled vessel by using a Rosette strain gauge. So before we start with the experiment, we should know what is principal strain. Okay, principal strain occurs on a principal plane. Okay, what is principal plane? A plane on which the shear stresses are zero is called as a principal plane, and the stresses acting on that is called as a principal stress, and the strain induced in that is called as a principal strain. And we are going to measure the principal strain by using Rosette strain gauge. So these are the observations that we have to make before we start with the experiment. The gauge factor is 2. Diameter of the cylinder on which we are going to measure the strain, principal strain, is of diameter 100 mm, and the thickness of the cylinder is 3 mm. Okay, that is given by capital T, 3 mm, and the material used for this cylinder having the Young's modulus E is equal to 2 into 10 raised to 5 Newton per mm square. Okay, and if you look at the observation table, the pressure that we are going to apply on this cylinder is 2 kg per centimeter square, 3 kg per centimeter square, and 4 kg per centimeter square. We are going to apply these 3 pressures on the cylinder, and we are going to measure the principal strain induced in the cylinder using the Rosette strain gauge. Okay, next we will look into the experimental part. Okay, here you can see the experimental setup of Rosette strain gauge. Okay, so this is the cylinder where we are going to apply the pressure. This is a here the pressure is applied through this pneumatic pressure. Okay, here you can see the pneumatic cylinder is there. By pedaling this, we can apply the pneumatic pressure in this cylinder. Okay, we can apply the pneumatic pressure in this cylinder, and on this cylinder you can see that the strain gauges are attached over here, and these are the positions of the strain gauges, strain gauge 1, 2 and 3, and the corresponding reading will be E1, E2 and E3. So this is the pressure gauge where you can see what is the pressure applied. Here in this you can see at the bottom kg per centimeter square is written. Okay, that is inner dial what we have to read, and for this experiment we are going to apply 2 kg per centimeter square, 3 kg per centimeter square and 4 kg per centimeter square, and corresponding strain will be read in this strain indicator. Okay, here you can see the gauge factor is set as a 2, and using this fine tune we can adjust the reading. Okay, we have to make it as a 0, and also using this course we have to adjust the readings. Now you can see this for channel number 1 for gauge factor 2, the corresponding reading is 0. Okay, we have not applied any pressure here. This is the initial reading for channel 2. Here it is, you can see it is 270 we can consider. This is for channel 3, and initial reading we can consider it as 2203. Okay, so this is the initial reading for channel number 3. Okay, next I will come back to the channel 1. Okay, it is 0, and now we will apply the pressure. Now you can see that in the dial gauge, pressure gauge, it is showing 2 kg per centimeter square, and the corresponding reading for the channel 1 is we can consider it as a 10, and we'll change the channel number 2 the corresponding reading we can take it as 277. Okay, initially it was 270, now it is 277. Next, we are going to change channel 3, and it is showing the reading 2212. So we have to subtract it from the initial reading. So this is first set of reading for the 2 kg per centimeter square. Similarly, we have to take for the 3 kg per centimeter square and 4 kg per centimeter square. Next, we will look into the calculation part of the experiment. Okay. After taking the reading, we will come back to this observation table, and here you can see we conducted the experiment for 2 kg per centimeter square, and we got the reading. Initial reading was 0 and we got it as 10, so I will write E1 as 10. At E2 initial was 270, and after applying the pressure we got it as 277, so E2 reading is 7. For E3 initial reading was 2204, and after applying the pressure it was 2212, therefore it is 08. So for pressure 2 kg per centimeter square, E1 value is 10, E2 value is 7, and E3 value is 08. Similarly, we have to conduct the experiment for 3 and 4, and we have conducted, and these are the readings. For 3 kg per centimeter square, E1, E2 and E3 are 16, 11 and 12 respectively, and for 4 kg per centimeter square, 21, 15, 16 for E1, E2 and E3 respectively. So these are the readings. We have done the calculation for 2 kg per centimeter square, and the students need to be done it for 3 and 4 with these set of readings. Okay, we will see the calculation part now. So this is the maximum experimental strain. So the formula is 1 by 2 E1 plus E3 plus 1 by 2 root of E1 minus E3 whole square plus 2 E2 minus E1 plus E3 whole square. So substituting the values of E1, E2 and E3 in the formula, we got experimental strain value as 11.24 microstrain, and we have to check with the theoretical microstrain, and this is the equation PD by 2TE, where P is the pressure in terms of Newton per mm square. So whatever pressure 2 kg per centimeter square is there, that we have to convert into Newton per mm square by multiplying 9.81 divided by 100, and by doing that we get 2 kg per centimeter square as 0.1962 Newton per mm square into D is the diameter 100 mm divided by 2 into thickness 3 mm and Young's modulus as 2 into 10 raised to 5, and solving this equation we get theoretical value as 16.35 microstrain. Okay, so this calculation we have done it for 2 kg per centimeter square. Student has to do it for 3 and 4 kg per centimeter square and tabulate the result. So this is the Rosette strain gauge experiment. Okay, thank you.